This video is about energy levels in atoms, so energy levels of electrons in atoms. So we need a little bit of recall from a previous topic in quantum, knowing that an energy of a photon is related to the frequency, and it's also related to the wavelength by these two equations. And this is a pictorial representation of an electron, and it's electron in its ground state in an atom. And the ground state is where the electron can be found in 99% of the time. So it's merrily sitting there, not doing very much, and then all of a sudden a photon comes in. And it has some energy, and the photon interacts with the electron, and the electron gains that energy, and it's said to become in an excited state, and by that we mean that it goes up to a higher energy level. So that's excited state, and the one on the bottom is the ground state. Electrons don't like to be in this state, and they would rather stay in their ground state. So what happens is they can come back down. So they can either do it in one of two ways, in which they drop back down to the ground state, in which case they would have to release some energy, or they could drop down a slightly different way to this step, and then down to this energy level. But all the time they end up back down to the ground state. So the second time, or the different way that they have dropped back down to the ground state, has been from 3 down to 1. So this one down here, or it could have jumped from 3 to 2, and then from 2 to 1. Each time an electron drops down, a photon is released, and the frequency or the wavelength of that photon is equal to the energy that has been lost. So if we recall, E equals hf or hc over lambda. So to recap, the energy comes in via a photon, the electron's in the ground state, jumps up to the third energy level, which is an excited state. The electron then wants to come back down, so it can either jump straight back down to the ground state from 3, in which case it lets off an energy, a photon of energy equal to the difference between these two energy levels. Or it could go down from 3 to 2 and from 2 to 1. Each time when the electron drops down, it has to release some energy in the form of a photon. So you can actually calculate the frequencies and wavelengths of photons and energy levels here. So you would get a photon that came in, and the electron would gain that energy, and it would jump up, say, to this level. So the energy here is equal to the difference between this energy level and this energy level. So 2.18 minus 0.14. 2.04 times 10 to the minus 18 joules. When that electron drops back down, you can do it in a different way than dropping back down to the ground state straight away, and it could drop down to this level, and then to that level, and then to that level. So we'll calculate the energy of the photons released. So each time the electron drops a level, a photon is released. So here it's going from 0.14 down to 0.24. So remember, it's the difference between the two energy levels that we're calculating. So that would be 0.1 times 10 to the minus 18. This one would be 0.3 times 10 to the minus 18. And then the difference between that will be 1.64 times 10 to the minus 18. Remember, they are all in joules. There are just a couple of things to add onto this. If a photon comes in and it doesn't have the exact energy difference, or it doesn't have the value of energy, which are the difference between two levels, in which case this one is 1.9 times 10 to minus 18 joules, it won't make the electron go up to that state. So let's say it had sorry, that should be 1.94. So if it didn't have exactly 1.94 times 10 to the minus 18 joules, then the electron would not go to that energy level. Let's say it had 1.9, like I wrote before, times 10 to the minus 18 joules. There is no energy level which is exactly 1.9 times 10 to the minus 18 joules away, so nothing would happen to that electron. The second thing to add is if a photon came in and it had more than 2.18 times 10 to the minus 18 joules, taken from this number here. If it had more than that, then the electron would be ionized, because this level here is the ionization level. So if a photon came in and the electron absorbed that energy and it was greater than 2.18 times 10 to the minus 18 joules, the electron would be ionized from the atom.